Here we go, Coach Jay in the house. Welcome to study session, Algebra 3, 4.5, 4.6. Hey, let's have a good time tonight. What you say? It's been a good weekend? It's been a great homecoming week. What do you say? Hey, as we get this underway, let's give you a couple things to highlight. Remember, part one of the review is due tomorrow. Part one of test is going to be taken tomorrow too, so make sure you study up for that. This right now is 4.5 to 4.6 review, just the graphing part. We might be able to get the second part in a little bit later. Couple things on today. If you have any questions, throw them out there at me. Text me, 770-757-2240. Text me a question on a specific one. We'll rock and roll. I am pumped and ready to get this underway. What do you say? All right. So as we start, let's get to it. Got questions, I've got answers. Man, 6 viewers, that's pretty good. 7 now. Let's get it rocking and rolling. We're going to turn off my favorite pump-up song, Eye of the Tiger, and we're going to transition to our graphing. One of the things to note here is that when I do this, when I show this graph here, this is what's going to be on the test, so I'll be giving that to you. Again, you'll be able to utilize that going forward, all right? So just kind of a heads up going forward on that. And again, if you got questions, throw them out there. We'll rock and roll. First off, I'd like to start off by doing one that's a little bit later, one that I know we'll end up getting to at some point, and that is numero 13. All right, remember with all of these, you will have a formula sheet that has a lot of this stuff on it. The only thing, kind of side note here, you probably need to just kind of keep in your back pocket. Tangent rises right, falls left. Cotangent rises left and falls to the right, okay? So just a heads up on that. Again, that's with tangent and cotangent. So just be sure that you know how to do both of those, all right? All right, now with 13, we have y equals -2 cotangent of pi over 2x, okay? Now, let's make sure we understand a couple things. First off, with tangent and cotangent, we need two different things. Number one, we need an amplitude. Number two, we need a asymptote. So again, if I'm able to solve for both of these, I really get half of the problem right based on what we're doing here. So amplitude being, and cotangent is going to be 2. I'm going to put an R next to it because amplitude's always positive, but because there's a negative out there, I know it's going to end up being reflected somehow. All right, so our asymptotes, you'll have this, but remember that with whatever follows the cotangent, in this case pi over 2x, we're going to set that equal to 2 things. Okay, so we have 2 things on this side, because again, we'll have 2 asymptotes. The first thing we set equal to is 0, and the second one we set equal to is pi. So the goal is to get x by itself, and we can do that by multiplying by the reciprocal there, okay? So if I multiply by 2 over pi, okay, again, it's the reciprocal. I cancel. And I do it to both sides, getting me x is equal to, well, 0 times anything is 0, okay? Also, we're going to do the same thing to the other side, 2 over pi, do it to both sides, 2 over pi, both sides, pi's will cancel, leaving me x is equal to 2. And by the way, if I say anything that you are confused on, text me, please, because that really helps me to see what I need to maybe do an extra one on and kind of go from there. So again, you are not offending me by telling me to do that, all right? So right now we've got 2 asymptotes. Again, cotangent we set equal to 0 and pi. Right now I want you in your room, wherever you're at, in your kitchen table, I want you to yell out what would you set tangent equal to? Yes, you, right now. Yes, every one of you. Good. Yell out loud. Again, your parents may think you're weird. It's okay. All right? So exactly. Tangent's pi over 2 and negative pi over 2 that we would set equal to in those spots, okay? So right now we've got 0, so we can just label this. So we're going to go 0 on one side. And again, this is exactly what you'll graph with on the test. So just giving you a heads up there. We'll put 2 here, and you'll also need the middle, which will end up being 1, okay? So we got our quarter points here. With cotangent, remember, will rise to the left and fall to the right. an important thing to note is that when I rise to the left, I will rise up to whatever my amplitude is. So since it's 2, we're going to put 2, and we're going to put -2 down here, okay? All right, so that's important. Now, as far as rising left, normally we would, but because this is a negative value, it's going to be flipped. So a cotangent that's negative will look like a tangent, and vice versa. If tangent's negative on the outside, it'll look like cotangent. So this case, we're going to rise to the right. So when I rise right, I'm going up to 2. And when I fall left, I'm going to go down to -2. So it should look like this. Boom. And this one will rise up. We're only looking for one period there. And so that would be sufficient in graphing that moving forward. Okay? Awesome. All right. So right now, we are progressing forward really well. Again, if you got a question, just keep it rolling. If you don't, then again, I'll keep doing examples and we'll keep flying through, okay? All right, let's look at the next one. Y equals tangent of x plus pi over 2, okay? All right, so this is just like the one. This is number 12, by the way. BT dub, as you all say in text world. Okay, so again, just like we did earlier, we have 2. Amplitude and the asymptotes there. Amplitude's the number in front. We know that that would be the value of 1, and it's positive. So because of that, again, if you remember this, rise right and fall left is what will happen between the asymptotes there, okay? As far as the asymptotes go, we have 2 of them. The first one is going to, again, whatever we have, right? So x plus pi over 2, whatever follows tangent, x plus pi over 2. We're going to set equal to 2 things, right? Pi over 2 and negative pi over 2, okay? So again, just like we have here, we have 2 equations. And again, by the way, I'll give these 2 to you. Okay, I'll give them to you. Now what we're going to do is we're going to subtract on both sides. Now this is something that a lot of people are going to struggle with because you always do the opposite. Don't multiply by the reciprocal here because we're adding. We have to think of the opposite, and that's why we will be subtracting here. So we cancel, cancel. Pi over 2 minus pi over 2 is 0. Okay, 0 there. We're going to do the same thing on this side. Subtract pi over 2. Subtract pi over 2. When I do that, I get x is equal to, well, this is different, right? If I have negative pi minus pi, negative pi minus pi, it's like I took away a pizza and then I took away another pizza, so you have -2, right? So we'll keep the bottom the same. So we have -2 pi over 2. Keep that denominator the same. That's important. So then I could cancel here and here, getting me negative pi as my second asymptote. Now, as I progress, right, we have our first one at 0. Okay, as long as you label, I'm good. The second one is at pi. We're going to get that second one at pi there. We have our middle point, our quarter points, okay? Got that there. And again, so we have beginning, middle, and end, and our quarters, right? So because it's a positive cotangent, we will rise to the right and fall left. And again, as long as I label, I'm good. So I'm going to give myself a little room, be able to rise up to my amplitude. So at this quarter point, that's where it rises up. At this quarter point, if it falls, I'm going down to my amplitude. So it should look something like this right there, okay? Again, I'm hoping that's helpful going forward. Let's check this out. I got a couple messages out there. Someone asked, could you do number 10? I would be glad to do number 10. Let's do that. Ooh, someone else put out number 10 too. Why is it at pi? It's a great question. Let's go back to this one. Before we move forward, I got a little shout out there. If you want me to give you a shout out, let me know. Otherwise, I won't. I'll keep your name anonymous. Some people love shout outs, some people not so much. So if you do want a shout out, throw it out there. I did get a question real quick. Why is it at pi when it's negative pi? Oh, that's a great question. Maybe that's because I messed up. That is my fault. If you looked right here, this should have been negative pi. Thank you so very much. If that happens, first of all, it's important to kind of go back through and check it, right? If I was grading this problem, just so you're aware, I would give you credit here, credit here, credit here. I would even give you credit on the graph and the amplitude, okay? But the problem is I would not be able to give you credit on the asymptotes. That's where I would count off there, okay? That's where I would count off. So just kind of make sure you do that, unlike myself. So if you did mess up on this, what you could do, you could redraw it, right? You could go left of 0 and go from there. But again, it's all about your labels, right? It's all about your labels. So if I come to this and I put 0 here, and I put, instead of 0 here, I put negative pi, well, that suffices. So we got 0 here, negative pi. And as long as I have the right labels, I'm okay. Again, your graph may look different. It might be skinnier, it might be wider. It's all dependent upon the labels. And remember, you do not have to have 2 periods, which will help, I think, in the long run there. Okay? Awesome. Great work. Let's look at number 10. That was a good question. And I apologize for messing up there. That's why I have y'all to help me out. I love that. All right. Let's check out this next one. Y equals -3 cosine of 2 pi x. And that is a good one. I'll be honest. That's a really good one. Remember, with cosine, sine, secant, and cosecant, there are 3 things we need to find. Amplitude, period, that's what the P stands for, and phase shift, that's what the PS stands for. So when I graph this, what I'm going to do is first figure out amplitude would be 3. And I'll put an R there because of that 3 that's negative. I know that it'll end up being reflected. That's important there. As far as the phase shift goes, you'll have this formula, but period is 2 pi over b. B, remember, is the value that's connected with x. It's always the value with x. And c is the value that is by itself on the outside. So since b is 2 pi, again, you'll take the whole thing, whatever's connected with x. That means that we have 2 pi over 2 pi. Now, I had a lot of people, especially, I even had my pre-cal students who struggled with what to do here. Well, just like before, if there's a 2 on top and bottom, I cancel. If there's a pi on top and bottom, I cancel that too. So 2 pi divided by 2 pi gets me 1. So I've got my amplitude, my period. Now I need my phase shift. So that is C over B. The hint is, remember that it's usually in parentheses with C, but there is nothing that follows the x. Therefore, there is no C. Remember, B was 2 pi. Well, 0 over anything is just 0. Okay. So when I graph this, what I have now is I've got my phase shift is 0. Remember, this is my starting point, right? So 0 is my starting point, and period is the distance I travel. This is not my ending point. Remember that. It's the distance I travel. So I'm going to add 1 to my starting point at 0. So because of that, my ending point will have to be at 1. So I start at 0, I end at 1. So this is where I come here. Again, your labels, as long as you label them, we're good. So I'm going here. This one's going to be 1. Middle is 1/2, and then I've got my quarters here. Okay. Now, one thing, my goodness, I'm off my game. I was thinking cotangent, my fault. I should not have asymptotes there, right? Remember, I should not have asymptotes on that, because the only time I have asymptotes, as far as like beginning and end, is when it's cotangent, all right? All right, perfect. The reason why C is not 2 is because when I look at this, remember my form is A cosine of BX minus C, okay? That's important. So like when I graph this, the B is connected to X, but if there's nothing on the outside representing C, then guess what? I've got no C, okay? There is no C. If you look back on I'm trying to look at one where there would be an example of one. Look at number 7. Number 7 is Y equals 3/2. And I'm not going to graph this, but I just want to show you the difference. Do you see how right here, there's something that follows the X value? So B is 2, and then the C is in parentheses, but it's added on or subtracted after the X. Therefore, the C is pi over 4 here. Whereas in this one, the C, there is no C because there's nothing that follows X, okay? Does that make sense over there? Ooh, the 2 pi. Oh, look, I didn't even see that. Actually, in my version, there is no +2. My fault. There is no +2. In fact, right now, from what I remember on the test, and I apologize for that, I'm looking at, this must be a different version, so correct me if for some reason there is anything that's different on this one, because the one I have right now, for some reason, is a little different, okay? So I apologize for that. The one that I have right now is this one. I do not have a +2 out here. So those of you questioning me right now, you're exactly right. I see what you were saying now. There is no, there is a +2. Let's do this. Let's drop that value because it is a little confusing and it will not be on the test. And so I don't want to confuse you right now with stuff that's not on the test going forward. Does that make sense? So if you graph just this one right here, you'd be okay. I'll finish this off just to make sure we're all good on here. So we have 3 and -3. Since it's reflected, we know that normally we would start at the top of the beginning, but because it's negative, we're going to start at the bottom. Where I start is where I will end up at the very end of my period length. So that's why I ended back at 1. Now, since I got to the top of this one, I'm going to go through the X. I'm going to go through both X's, and it's going to meet right at the top of my maximum level at 1/2. And so it should look like that for my cosine. Just a heads up, if this was a secant graph instead of cosine, the only difference is I would have asymptotes right here. I'd still graph it the same way, and I would have a graph, or I have a parabola going down, up, and I'd have one going down right here, okay? And that would be all I would need to do there, okay? Great questions. I apologize. Let me know if there are any things that are different. I thought I have the correct one, but there must have been a few things that I tweaked and I just forgot about it. Okay. Does that make sense to everybody? Hopefully that does. I apologize again. I should have done that one, but the +2 on the outside that's not in parentheses will not be a C, and we won't have that on the test, so don't worry about that, okay? All right. Fantastic. Got some more out there. Number 7. Is another one. We're actually just put that down. Y equals 3/2 cosine of 2x plus pi over 4. Remember too, because I am moving pretty quickly, if for some reason you have questions and I don't address that question, please make sure you let me know so that we can go through it a little more slowly there. All right. Fantastic. Okay, perfect. I also see a couple other ones out here. I'm going to get to number 15 here in a second too. We put 15 out there just so we got it. 15. Is that y equals 2 secant of x? Correct me if it's not. Again, make sure this one should be 17. This one should be 15. If it's not, I'll give about 20 seconds just to kind of help me with that, okay? Perfect. Yeah, okay, so I got a question out there. Is negative tangent graph the same as cotangent? The answer is yes. So if there's a negative on the outside of a tangent graph, it will be graphed like a cotangent, where it would rise to the left and fall to the right, okay? It's a great question. I know I'm dressing a lot of these. Y'all are awesome. I love the engagement that y'all have. Again, appreciate y'all going forward. Keep it up. All right, so let's take a look at this. First off, this is actually pretty good because this secant graph, we're going to end up graphing it like it is a cosine. Remember, cosine and secant go together, whereas cosecant goes with sine. So this one, we would still find the same things. Nothing changes on either of these two. Maybe a little more difficult on one than the other, but the process is still the same. So over here, we know that the amplitude is 3/2, whereas the number 15 is 2. Okay, we've got that there. I'll stick to this side, and then I'll come over to the right. So as the period comes, we know the period is 2 pi over b. And because the b is 2, we have 2 pi over 2. Now, since there's no fraction over fraction, we can simply cancel, leaving me with a distance of, distance of pi there, or a period is pi. Now, for our phase shift, we're going to do c over b, whereas c is the outside number, pi over 4, and b is the value of 2. So we're going to put that as 2 over 1. Now, some of you do it a little different. I'm going to make sure I stay consistent with what I've done, but if you have a different way of simplifying this, let me know, all right? All right, so what we're going to do is we're going to take this one to the bottom. We're going to flip it to the top. And so it should be pi over 4. Now I'm going to rewrite this here. Pi over 4 multiplied by 1 over 2. So when I multiply this across, my answer is going to be pi over 8 as my phase shift. Now, someone just asked me, Coach, could you look at just kind of adding, what that looks like to add and that sort of thing when you have two different values with period and phase shift. Well, first off, since this is positive in here, we know that this will end up being a negative pi over 8. All right. So again, what you could do is since this is, I'm sorry, I've got a question right here. I apologize. Someone just came through. If someone has DT's number, would you mind texting him the YouTube link real quick? If you could do that, that'd be awesome. I don't know if he's signed up to Remind 101. So if you could do that, that'd be awesome. Okay, back to the problem. Negative pi over 8. I'm sorry, I'll do it in a different spot. Let's go right here. That's fine. Negative pi over 8 right here is our starting point. And what I'm going to do is add pi. Remember, this is not my ending point. All that means is I'm adding pi to negative pi over 8. Okay? So when I add these two together, the important thing to note is when I multiply, like right over here, multiplying two fractions, I don't care if they have the same denominator. Whereas when I add, I do. So in order to combine these two together, I've got to put an 8 on bottom as well as an 8 on top. So I have negative pi over 8 plus 8 pi over 8. Well, when I add, I know that the bottom always stays the same once I get a common denominator. So then I say negative 1 or negative pi plus 8 pi would be positive 7 pi. So that right there is my end, where the negative pi over 8 is my beginning. So you could do it in a number of different ways. Like I said earlier, what you could do, as long as you keep it consistent, I'm good. So you could say, okay, this is negative. I'm sorry, let me back up. I keep doing that. I don't know why I keep doing the asymptote. I got a little happy with the asymptotes there. Okay, so there's the, oh my goodness, there I go again. Woo! All right, it has been a good weekend, I promise. All right, so what I'm saying is that my starting point will be here. There you go. And that's at negative pi over 8, okay? The end would be at 7 pi over 8, all right? So what we're going to do is I'll put it over here. That's fine. And that's 7 pi over 8. Now, one of the problems that a lot of people have is determining what the middle value is. What is that value? Everyone knows here's my quarters, right? But trying to find that middle value becomes tricky. So what you could do is, if you know that it's counting by 1/8, try this. Try labeling it on the side. Watch this. Negative 1/8, 0, 1/8, 2/8, which I know can be reduced. Just go with me. 3/8, 4/8, and keep going. Now, I know that this can be kind of monotonous a little bit, and I get that. But once I know what my beginning and end are, what I can do is cross these out, one on each side, to figure out what my middle is. In this case, 3 pi over 8. And what I did right there was, and this is a pretty tricky problem, I get that. But what I did was I was able to find my beginning and middle, or beginning and end, and then be able to find it using my middle. Be careful right there. That doesn't necessarily mean that's not necessarily the case. Someone asked, can't your period just be your middle? Be careful on that, because that would mean that the period pi would be my middle here, and that's not necessarily the case. Remember, period is the length I travel. Got me? The length I travel. So if I start here, I will add pi to it to get to my end, which was 7 pi over 8. Remember, that's how I found this right here, right? To find my middle, a lot of times, sometimes it's easy, right? Sometimes it's easy. Sometimes you have, let's say, I'm trying to think, if I had one that was like negative pi and pi were my start and end, right? I know my middle would be 0. That's pretty easy. But one like this, and I don't think it's going to get more tricky than this here, you may need to just kind of, if you can't see it, may need to just count down and just kind of do it by, finding the middle value there by going by 1/8 or whatever it may be there. Does that make sense? I hope that makes sense. If it doesn't and you put down that message, please let me know. Asymptotes, I'm going to get to that in just a second. So let's do this last one here. All right, so now since it's cosine, let's go to the amplitude. So we got here, we know it's 3/2 up, 3/2 below. Since it is a positive cosine, we start at the top of that first value, which means if I start at the top at the beginning, I'm going to go through the x. I'm going to hit the bottom of this middle value, go through the next x, and hit the top of the next value. And right there, that would be my cosine graph. Okay. Awesome. Where do I use asymptotes? Well, there's only two places that you really do: cotangent and tangent, right? We talked about that in previous parts of the podcast. And then also secant and cosecant. With sine and cosine, don't worry about that. That's not a part of the problem. The only time I need to do that is with cosecant and secant, and cotangent and tangent. Now remember that with secant here, though, and I'm about ready to do this one on number 15. When we think about secant, one thing to remember is, again, 2 pi over b, right? B is 1, so 2 pi over 1, right? Because this one value is attached. So we got a period length of 2 pi, okay? Phase shift is c over b. C is 0, right? There's nothing that follows x, so it's 0 over 1, which would be 0. So what I've got now is I've got my amplitude right here at 2. Again, I know it goes up 3, but as long as I label, I'm good. My starting point's going to be at 0. I'm good there. And I'm traveling 2 pi. So again, if I start at 0 and I add 2 pi, my ending spot would be 2 pi. Okay, so we're going to put that there, 2 pi. I then look towards my middle. My middle level is pi there. Okay, and again, hopefully you could see that between 0 and 2 is 1. Okay, so once I gotten this here, I've got positive 2 secant of x. So I'm going to graph cosine positive. So I'm going to start at the top, just like I did last time. Go through the x, hit the bottom at pi, go through the x, hit the top at 2 pi. Now, other than tangent and cotangent, when we talk about asymptotes, secant and cosecant, we graph it just like cosine and sine. Secant goes with cosine, cosecant goes with sine. And then what I've got is I've got a parabola that goes down and that goes up, just like that. Okay? And that right there would be my answer. That'd be the answer of my graph right there. Okay? All right, hopefully that's helping. Again, hopefully that's helping there. If you have questions on any of those problems, please let me know. I know good night. We've already gone through like 5 or 6 of them. And so great job. Keep bringing in the questions there. Oh yeah, let me go back here. I just got a question. Perfect. Anytime, remember I start at my beginning point at 0, I start at the top or bottom when it's cosine, right? Remember, let me back up here. I'm sorry. Remember that when I talk about cosine, that's positive. At my beginning point, I start at the top. If this was a negative 3/2, I would start at the bottom. If this was a positive sine, I would start through, right? That's probably what you're saying, where it would go up, touch at the top of x, go through pi, touch at the bottom of the next x, and then come up through 2 pi. That's positive sine, right? Negative sine would hit at the bottom, come up, hit the top, come down. And so that's important. Knowing the difference between sine and cosine and how I start, that's very important going forward, okay? Awesome. Hopefully that helped. Again, if I didn't explain something or if you had a question on something, throw it out at me again, because maybe I didn't explain it the best I could, and I'd be more than willing to help you out again. So throw out any questions that you have again, and we'll keep looking at it. All right? Awesome. Okay, let's see here. Let's see if I've got some more of that. All right, let's see if we have any other ones that were good. I like all the ones that, man, a lot of these, it's just trying to dissect it, right? So like, for instance, like 18. 18 is a cosecant one, so we're going to graph it like sine, right? So the individual that talked to me just a second ago about, hey, coach, why do you start at the top? Why don't you go through? Well, you're going to see here that with sine, because sine and cosecant go together, that with sine, it's going to go through that first point rather than going at the top. So let's take a look at that, okay? And yes, then I'll go to number 14. I'll do 14 next, okay? So we have amplitude, period, and phase shift, right? Amplitude's the first number in front, which would be 1. Period's 2 pi over b. Since b is 1, it'd be like 2 pi over 1, which is 2 pi, okay? Not 2 pi, 2 pi, okay? Make sure that's a lot of people mistake that, So just be careful, all right? Phase shift is C over B. All right, C would be the pi over 2, and B would be the 1. Well, anything over 1 is itself, so we just say it's pi over 2. And since this is a negative value, we think opposite, so we start at the right, pi over 2. Now, this one is a really good one, because if I start at pi over 2 as my phase shift, okay, and again, maybe you start here, maybe you start somewhere different, it's up to you. I'm going to add whatever my period is, in this case 2 pi, to my starting point, pi over 2. So I'm going to put a 2 on the bottom. What I do to the bottom, I do to the top. Pi over 2 plus 4 pi over 2 gets me. Remember, the 2 stays the same on the bottom when I add. Now, when I multiply, different. But when I add 2, keep that there. 4 pi times pi, or 4 pi plus pi is 5 pi. So my ending point is 5 pi over 2. Okay? Again, yours may be a little bit bigger, and that's okay. You only need one period. Okay? Now, I don't know why I keep doing this. You all need to just stop me. I've never done this in my life. Why am I using asymptotes? And that's probably why those of you who are asking about asymptotes, you're confused. I apologize. Remember, let me make sure I say this because I'm messing up. Sine, cosine, cosecant, and secant, cotangent, and tangent, right? These right here use asymptotes, right? And the secant and cosecant will use asymptotes at the very end, right? So these will actually start with it, cotangent and tangent. And sine and cosine have none there, okay? Good question. Why did I add 4 pi to it? Remember that right here, right? I added actually 2 pi, if you remember, because that's the period. But in order to add these two together, I've got to put a 2 on the bottom. What I do to the bottom, I've got to multiply the top by that to get 4 pi over 2, right? I'm just trying to get common denominators. That's it. So that's why I got to 5 pi over 2 at my end there, okay? So some of you may actually be able to see, hey, oh yeah, this is what's in the middle. But in case you can't see, since it's over 2, each of them, we'll do the same thing like we did the other problem. Add 1/2. 1/2 plus 1/2 is 2 halves, 3 halves, 4 halves, 5 halves. Good night. This is a weird day. Sorry about that. So 1, 2, 3, 4, 5. This is my end. This is my beginning. I know that my middle value will be 3 pi over 2. And again, I noticed that because as I count from 1 over 2 forward, I know my beginning and I know my end, and I can use that to be able to figure out what my middle is going forward. Okay? All right, let me see if I've got any questions here. Hopefully that made sense there with the 2 pi, why I added 2 pi. It wasn't 4 pi, I'm adding 2 pi, all right? So I come here and here. I know that this cosecant's positive, so we're going to start here because, again, we're talking sine, right? Now, if it was cosine or secant, we'd start at the top or bottom depending on whether it's positive or negative. But since it's sine that's positive, it's going to go up, touch at the top of x, right? Come down, touch at this point in the middle. I'm going to come down again, touch at x, and come back up through 5 pi over 2, okay? Now, I'm still not done. Because now what I need to do is, because it crosses, we're talking about cosecant, right? Now, if it was sine, we'd be done. But with cosecant, wherever it hits the x-axis, so 1, 2, and 3, okay? I'm going to go down, just like so, okay? And I'm going to go up, up, down, down, okay? And that's all I need to do. And I've got it, okay? Awesome. Awesome, awesome. Okay, I'm trying to check this out, make sure that everyone's good on this one. 16. Did we do 16 yet? I don't think so. We can do 16. And number 14. Hopefully I helped with that. Another way to find the middle is you can add these two together and divide by 2. So pi over 2 plus 5 pi over 2 is 6 pi over 2. Multiply by 1/2 to get 3 pi over 2. You could do that. Again, there's multiple ways to kind of find the middle. I've taught it a couple of different ways. Whatever floats your boat. The big thing is probably finding what your groove is, right? What you do well, and then kind of going forward off that one there. Okay. Let's check out number 14. 3 cotangent of x plus pi over 2. Okay, again, with cotangent, we have two. We have amplitude and we have our asymptotes. Now, with this one, we definitely are using asymptotes here. Okay, in fact, at the very beginning, we will. So the amplitude in this one is +3. Okay, the ones you draw the parabolas for, while I write this amplitude down, the ones you draw the parabolas for are cosecant and secant, those that just asked that question. So cosecant and secant, remember you graph the sine or cosine of it. Remember cosecants with sine, secants with cosine. Then once I graph that, wherever it hits the x-axis, I've got my asymptotes with the parabolas there as well, okay? Now with my asymptotes, whatever follows that cotangent, the x plus pi over 2, that is what we're going to set equal to whatever values we use for cotangent. Now I'll give this to you on the test, but you should know that it's 0 and pi. All right, again, I'll give that to you, but we set it equal to 0 and pi. Now once I subtract pi over 2, okay, we subtract it to get x is equal to negative pi over 2, right? Because there's nothing here, and we have negative. Now we subtract negative pi over 2 to the second equation. Just like I did before, I can't subtract this unless I have a common denominator. So if I put a 2 on the bottom of pi, I've also got to do it to the top. So I'm not subtracting 2 pi, I'm subtracting 2 pi over 2. So 2 pi minus pi is just 1 pi, and then we keep the denominator the same. So my two asymptotes are at negative pi over 2. I'm going to do it over here just because I know some of you prefer it like this. Negative pi over 2 and pi over 2. Now that should be pretty easy to find the middle, shouldn't it? Because if you go right 1/2 and left 1/2, the answer for the middle would be 0. So then we got quarter points. And because we're talking about cotangent that's positive, we'll rise to the left and fall to the right. Now, if this was negative, we would flip it and it would rise to the right and fall to the left, but it's not. So we'll rise left and fall right. So it's gonna, when it rises left, it's going up to my amplitude. When it falls right, going down to my amplitude of 3, because right there, right? That's where it comes into play. So that's where I got this graph right there to the top left and the bottom right. Just like that, okay? Awesome, 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 very good. Let's do 16, I think it was 16 that I got asked on. Y equals -2 cosecant of pi x. Again, just like we talked about before, cosecants with sine, right? So let's graph sine first. So we have 3 parts: amplitude, period, and phase shift. One thing you probably want to note here, just kind of keep a note section here, is, hey, don't forget asymptotes, right? Okay, you might want to just put that down to note that, oh yeah, I can't forget that, asymptotes and also parabolas. That's a really important thing. So maybe some notes right there will help you not to forget those things on that test. So you could just put them on next to a problem or so, okay? Now, because of the amplitude is 2, but we're going to put an R there because of that negative there. It's reflected, okay? So we're going to keep that 2 there. Get a little lighter color there. There we go. A little R, okay? Period is 2 pi over b. In this example, b is pi, right? It's whatever's attached to x. So we have 2 pi over pi, okay? So we'll cancel, leaving me with the value of 2, okay? Now with my phase shift, one thing to remember with my phase shift is when I have c over b, there is no c on the outside. So because of that, we have 0 over a b, which is 0. By the way, your phase shift will never be undefined. So just a heads up on that, will never, ever be undefined there, okay? I know I got a couple questions, so I want to make sure I address that. All right. Why do I circle the points? I'm trying to think. Why do I circle the points? I'm sorry. I'm trying to see what you're saying. Trying to circle the points. Are you saying this right out here? I'm trying to see that. I'm circling to hopefully make a point here, like with period, phase shift, trying to tell you what B is. A's out here. There is no C, right? So I'm not sure on that one. We could maybe come back to that if you have a question there. But my phase shift is my start point. That's 0, right? So we got my 0. Put that there. Okay. Oh, it's the one before. Okay. I'll go back to that one. I think I could maybe go back. It might take a little bit, but I will. So hang tight with me. We'll look at that one in a second. Now what we're going to do is we're going to add our period, which is 2, or just 2, right? So my ending spot would be 2. So I start at 0. I'm going to end up at 2. Now, one thing again that you're going to see here, and I do it every single time, you just got to be careful of, is my starting point is at 0, right? And a lot of times I'm just used to doing the cotangent and tangent. But I know that I'm graphing sine, right? So I need to graph it that way. My middle's 1. I've got my quarter points there. I'm going up 2 and down 2, right? And because it's a negative sign, I'm going to start at the beginning point right here. And I'm going to go down, okay? I'm going to hit my x. Coming back up through 1. Coming back up through x. Coming back down through 2. One thing that I continually see, and I'm just being honest, is I'll see this. I promise you tomorrow I'll see this on the test. Someone will do this. I promise you. Come down, and they'll say, Coach, I did a pretty good job there. Well, the problem is you just did 2 periods, period 1 and period 2. But in actuality, all I need is, see if it'll come back here. All I need is this. So that's why we only have from beginning to end. That is a period length, and that's all I'm needing. That's all I'm needing for tomorrow, okay? Now with cosecant, we go through where it crosses at the x-axis. Crosses there, crosses there, crosses there. And then we do a little parabola up, and over here we do a little parabola down, okay? And again, that would be my answer there, okay? All right, hopefully you got that. I'm going to back up just a little bit, give you just a little bit of time. It's about that time. It's been about 45-minute podcast there. Hopefully this has been helpful. You draw the parabolas on 2 of them, cosecant and secant. Remember, you have to draw the cosine and sine first with secant and cosecant. And then once I draw the asymptotes, that really helps me to be able to then find the parabolas between the 2 asymptotes there, whether it's up or whether it's down, okay? Awesome. I am backing up really quick to address that secant graph, but if you have any last-minute questions, you could throw them out there. I know that there are a lot of people out here today, which I completely appreciate. Keep that up and keep it classy, okay? All right, it has been 45 minutes. I know I got one more here. Someone just did put down number 8. Tell you what, tomorrow morning, number 8, if that was you, you could come in the morning. We can look at that one together. I also have the answer sheet that's posted online. It should be on there. It should be on the sections, so you could check that out and go there and go from there. I've just got a little daughter to put to sleep tonight, so I want to make sure I get in there and do that for her. And go from that point. So thank you so much for understanding tonight, and thanks for giving me your effort. Man, I tell you, y'all have done a great job of that, and I look forward to getting after it tomorrow. Awesome. And I think that's it. Oh, I thought this was the secant one. As far as that individual that talked about the secant one there, I apologize for that. I don't have the secant here. I don't know why I circled the numbers. Maybe I was just trying to show something. I could go back on the podcast. Maybe I showed it or didn't show it. But if you want to come in, we can look at that one together and go from there. But I'm not sure why I circled it. Apologize for confusing you if I did there. Again, hopefully you all have a great night tonight. I appreciate your effort there. That really means a lot. And hey, get after it tonight. Get some sleep. Do your very best. That's the big thing. And the fact that you're at this podcast, I have 10 viewers down below. That says a lot about you and where you're at, okay? So don't stress. Do your very best. Remember, each problem has 6 different components, which helps you out. So show your work. Do the best you can, and know that I'm on your side, and I want to give you as many points as possible through the way that you show that problem. So know the basics, study it up, and get after it. Tomorrow morning, 7:15, I will be in there if you want to come in. We'll be doing some problems together there, and we'll be rocking and rolling. Thank you. Care about y'all. Love y'all. Have a great night. See ya.